Welcome to this video from Derby Physics Tuition, and I've been working with a student studying IGCSE Physics, and at the moment she's studying Unit 5, the Solids, Liquids and Gases unit, and this is a past paper question that involves the physics from that unit. So let's get straight into the first part of the question. So the question is about pressure in gases, and part A, photograph 1 shows an open conical flask containing air. The air in the flask is heated to a temperature of 85 degrees Celsius. Calculate the temperature of the air in the flask in Kelvin. So the way that you convert from degrees Celsius to Kelvin is you take the temperature, which is given as 85 degrees Celsius, and you add 273 to it, which gives you an answer of 358 Kelvin, and that is the first mark. And part 2 of the question, describe how the motion of the molecules in the flask changes when the temperature of the air inside the flask increases. So the first thing that will happen is that when you increase the temperature of the air, the kinetic energy of the molecules increases. Okay, and if the kinetic energy of the molecules increases, then that will mean that the mean speed of the molecules increase. And that is how you get your 2 marks there. So I've bullet pointed them to make it clear that what the 2 separate points are. And moving on to part 3, the pressure of the air in the flask does not change when the temperature of the air increases. State what happens to the number of air molecules in the flask when the temperature of the air inside the flask increases. So basically, if the pressure is going to stay the same, now normally when you heat up a gas, the temperature of the gas will increase, but the question is stating that the pressure of the gas will increase, but the question is saying that the pressure of the air in the flask doesn't change. Now the reason it doesn't change is because some of the molecules have been given kinetic energy by the increase in temperature, and they have escaped from the flask. So if some of the molecules have escaped, then the number of molecules inside the flask will decrease. And that is all you need to put for the third part 3 of that question. So what have we got? We've got photograph 2 shows a boiled egg without its shell placed in the top of the conical flask containing hot air, and the flask is no longer being heated. So it was heated before, but the flask is no longer being heated. The egg seals the flask so that no air escapes, and photograph 3 shows the egg a short time later. So there's photograph 3, and it looks like the egg has been sucked into the bottle. So the question is, explain why the egg moves down the flask and then stops moving. Refer to ideas about pressure in your answer. So they're giving you a bit of a clue there, and there are 4 marks for this question, and there are 2 points to answer here. First of all, you've got to comment on why the egg moves down into the flask and then why it stops moving. And you have to refer to ideas about pressure in your answer. Okay, so quite a lot of work here for 4 marks to explain this properly, and we'll go through how I would answer this question. So what's the first thing that happens? Now the flask is no longer being heated, and if it's no longer being heated, that means that the air in the flask cools. So if the air in the flask cools, the molecules in the flask will slow down. Okay, if you're reducing the temperature, the particles will have less kinetic energy, so their mean speed will reduce. Now pressure is caused by the particles colliding with the inside of the container. So if they slow down, then there will be fewer collisions every second, and so the pressure inside the flask will decrease. Now what that means is that the pressure outside the flask, and where is the pressure outside the flask come from? Well, there are particles of air, molecules of air outside the flask, and they are colliding with the flask, and they're colliding with the egg as well. Okay, so the pressure outside the flask is greater than the pressure inside the flask. So what that then means is that there will be a resultant force which pushes the egg into the flask. So we've got a resultant force which pushes the egg into the flask, and so the egg gets pushed down, as you can see in photograph 3. Now that's explained why the egg gets pushed down, but why does it stop moving? Okay, so as you push the egg, as the egg gets pushed into the flask, then the volume of air will decrease. So you can see here that the volume of air is being decreased because the and this is the air I'm talking about, the air inside the flask will be decreased because the egg is being pushed down. And so because the volume is being decreased, then the pressure inside the flask increases, and that's Boyle's law, which states that the pressure of a gas is inversely proportional to the volume. So let's write that mathematically. Pressure of a gas is inversely proportional to the volume for a fixed mass of gas at constant temperature. Okay, so if the volume is going down, then the pressure must go up, okay, because that is what Boyle's law states. So eventually the pressure inside the flask will equal the pressure outside the flask. Now when that happens, when those two pressures become equal, then that will mean the final point is that there is no resultant force. Okay, so let's just so this downwards force will disappear because the pressure outside the flask equals the pressure inside the flask, and we have explained our final point, which is why the egg stops moving. So a lot of work for 4 marks there to actually explain that properly. And to add to this explanation, I've replicated this experiment with a boiled egg being sucked into the conical flask, and then eventually it stops moving. So we'll move on to that video, and you'll see this experiment actually happening. So I'm going to add a burning piece of paper into the flask, put the egg on top. Now the heat from the burning paper drives some of the molecules out of the flask, reduces the pressure inside the flask, and the pressure of the air outside of the flask pushes the egg in.